Hi, I want to show you a quick trick which can be used to override or augment the default refinement mode for atoms used in crystals. So as you probably know, when you choose to set up a refinement, you have several options. You can just refine scale factor and positions of atoms, scale factor positions and isotropic displacement parameters, or scale factor positions and anisotropic displacement parameters. And on top of those, there's specific commands for what you want to do with the hydrogens. Sometimes it's useful to use a mixture of these two things. One case is when you have disordered regions where the displacement parameters overlap slightly, and you might want to use a simpler isotropic model for those atoms instead of anisotropic, but keep the rest of the structure anisotropic. And in other cases, maybe you just need it isotropic for a little while the model settles down. So we're going to have a look at an example of that today. So let's start by refining the structure. Everything looks okay. If you've seen, there's another video about using parts in crystals, and that shows what I'm going to show you again here, how to locate a second component using a difference Fourier map of this SO3 group of this tosylate ion, and then start to refine it. So we'll just quickly go through that. We run a difference Fourier map, click OK, transfer the peaks into this peak viewer. We note there are 3 big peaks. We find those 3 big peaks by sliding this slider across until there's only 3 left. Oops. There they all are in the SO3 group, and then we can quite quickly change those into oxygen atoms. If you want a little bit more explanation about what's going on and how we're building this model, then there's a link below to another video that goes through this a little bit more slowly. So we're going to start by setting occupancies of all of these atoms to 0.5 to represent a 50-50 mixture of 2 conformations of this ion. We're going to put one of the groups of atoms into a part called 1001, which represents assembly 1 and group 1 of this disorder, and the other into part 1002, which represents assembly 1, group 2 of this disorder. And once we've done that, we can see the disorder slightly more clearly, and we can use this tool here to visualize the different bits one at a time. Now, one problem when you start refining disorder, especially when the occupancies might not quite be right to start with, is the displacement parameters will go a bit crazy. So refining anisotropic displacement parameters for atoms that are possibly not quite in the right position and possibly haven't got the right occupancy sometimes can cause your model to diverge and the atoms will fly off in all directions. So a cautious approach would be to refine everything isotropically, but of course we don't want to convert our whole model to isotropic atoms because we've already done a lot of work refining anisotropic atoms for the rest of the structure. So I can just select the atoms that I want to refine isotropically, and then from this menu right down the bottom there's a refine mode, and I can choose just X's and UISO for the selection, and that applies to those atoms. If I look in the list underneath, it actually tells us that for these 3 oxygens here and these 3 oxygens here, we're only going to refine X's and UISO. Everything else will be refined as we specify in this setup dialog here. So anisotropic refinement and positions and scale. So I click OK. These will be converted to isotropic atoms and the refinement commences. And that gives us a slightly more stable refinement, and the occupancies you can see have changed quite a lot, and so that would have been bad news for the displacement parameters. They'd have got too big or too small in the first cycle of refinement. Once it's settled down, the thing hopefully comes back together, but this little trick allows you to build or refine a simpler model without having to worry about that kind of thing. And when you're done, you can select the atoms again. You want to go back to refining everything, and we can just clear the refinement mode. They disappear, and then when we refine, everything will be refined as before. There's actually this other option here, override sticky settings, which also ignores the flags in this column here, so you can use it to override those manual settings as well if you like. And there we go, back to a slightly more stable anisotropic refinement of the disorder. Bye.